Example 4 says find all the solutions of these equations. Part A wants us to solve the equation 2 times tangent of theta plus 1 equals 0. And we have a tip here that says isolate the trig function on one side. So in order to do that, I'm going to subtract 1 from both sides of the equation. And we'll get 2 times tangent of theta equals negative 1. And then if we divide both sides by 2, we get tangent of theta is equal to negative 1/2. Now, from here, I want to apply tangent inverse on both sides of the equation. And so we end up with theta equals tangent inverse of negative 1/2. Now, I'm just going to draw a quick sketch of tangent inverse. So here's negative pi over 2, here's positive pi over 2. And the graph of tangent looks something like that. And so if this was negative 1/2, we are trying to figure out the x-coordinate of this ordered pair, or the theta value that gives us an output value of negative 1/2. And because tangent is periodic, just like the other ones, there are going to be multiple. If this is negative 1/2, then there's going to be a point of intersection there and a point of intersection there, so there are going to be infinitely many solutions. But hopefully the calculator will help us find one of those solutions. So I just want to make sure my calculator is in radians, which it is, and now I want to do tangent inverse of negative 1/2. And that is going to be negative 0.46. And I want to make sure that I include all of the other solutions as well. So I'm going to do plus, and unlike sine and cosine, the period for tangent is pi. And so instead of writing 2 pi k, it's going to be pi k, where k is an integer. So that is our answer for example 4a. All right, example B says sine squared theta minus sine of theta minus 2 is equal to 0. And our tip here is use factoring and the zero factor theorem. You might have also heard me call this the zero product principle. Those are synonymous. Okay, so how I want to go about doing this is I personally have an easier time factoring this when there is a variable other than sine of theta. So what I like to do is I like to let w equal sine of theta, and we can always substitute it back in later. And so if we do that, our new equation is going to become w squared minus w minus 2 equals 0. And that, is a quadratic now, and for me, visually, it's a little bit easy to factor. So I always revert back to the x method when factoring. I am seeking two numbers that add to negative 1 and multiply to negative 2. So the numbers that do that are negative 2 and positive 1. So now I have that this factors into w minus 2 times w plus 1, and that is equal to 0. Now I can use the zero product principle or the zero factor theorem to set each of the individual factors equal to 0, and if I solve them, I get w equals 2 and w equals negative 1. Now I can substitute back in, and both of these equations are going to say sine of theta is equal to 2 and sine of theta is equal to negative 1. Now, for this equation, we know that the output values or the range values for sine are all of the numbers between -1 and +1. Therefore, this particular equation has no solutions. So let's move on to solving the other equation, which is sine of theta is equal to -1. So if I'm on my unit circle, sine of theta is equal to -1 when we are at the very bottom of the unit circle where the terminal point is 0, -1, and that angle happens to be 3 pi over 2. So we get that theta is equal to 3 pi over 2, but we also want to include all of the coterminal angles as part of our solution. So I'm going to do plus 2 pi k, where k is an integer. So this is our final answer. And again, remember that this equation produces no solutions since 2 is outside of the range, so there is no angle theta such that when you take sine of it, it'll give you an output value of 2. All right, part C wants us to solve the equation 2 times cosine squared x minus cosine of x minus 1 is equal to 0. I'm going to go ahead and do that substitution again that we did earlier. I'm going to say let w equal cosine of x, and that just makes things a little bit easier for me personally to see what's happening. So then I have 2w squared minus w minus 1 is equal to 0. Now, here is an example where our leading coefficient is not 1. So in that case, we have to use the x method and then factoring by grouping. So in the top of my x, I put the b value, which is -1. And then on the bottom of my x, I put a times c, which is 2 times -1, and that's -2. So I am searching for two numbers that add to -1 and multiply to -2. And the numbers that do that for us are -2 and +1. So this is going to factor into, oh, excuse me. Before we get into the factoring, I'm separating the middle term so that I can rewrite the equation as 2w squared minus 2w plus w minus 1 is equal to 0. Now, in the first two terms, I can factor out a 2w, and if I do that, I'm left with w minus 1. And then in the second two terms, I'm just going to factor out a 1, which doesn't really change anything. But now notice that I have a w minus 1 here and a w minus 1 there, and now I can factor out w minus 1. And then the thing that will be left over is 2w plus 1, and this is equal to 0. Now I can use the zero product principle or the zero factor theorem to set each of the individual factors equal to 0. So we're going to get w equals 1 and w equals -1/2. And if we sub back in the cosine, our equations are going to be cosine of x is equal to 1 and cosine of x is equal to -1/2. And so these are the two equations that I want to solve. So for the first equation, cosine is equal to 1 right here, because that terminal point is 1, 0. And so that angle is 0, or it's also 2 pi if you make a full rotation. So the way that I'm going to think about the solution to this equation is x is equal to integer multiples of 2 pi. So I'm going to write it as 2 pi k, where k is an integer. So this is part of our final answer. And then we still need to solve this second equation here. Cosine of x is equal to -1/2. So if I draw my unit circle, there are going to be two locations where the x-coordinate is -1/2. And so my job is to figure out what angles those are happening at. And the first angle, we know from the unit circle, this is equal to 2 pi over 3. And then the second angle, which is that one, is equal to 4 pi over 3. So our final answer for this component is 2 pi over 3 and all of its coterminal angles, as well as 4 pi over 3 and all of its coterminal angles. And that concludes part C.